In this lesson, we're going to talk about factoring. And factoring is the process of finding all factors in a product. And now there are different methods to factor. I'm going to do a few examples of each, and then we're going to kind of put it together and look at the big picture. So in the first method, we're going to do what's called pulling out the greatest common factor. And so you want to look to see what factor each term has in common. So terms, just a quick refresher, terms are separated by plus and minus, and factors are separated by multiplication. So, for example, if I gave you 3x plus 7y minus 2, I would have 3 terms because I have a 3x and then I have a plus, and I have 7y and a plus, and then I have the 2. So this is 3 terms, and each term is separated by the plus and the minus. For example, 3x plus 1 times z times y, I would have 3 factors. This is a factor, this is a factor, and this is a factor. That is what is being separated by the multiplication symbol. So here I have 3 factors. So just a quick review so you understand the terminology here. Okay, so now looking at example A, we're going to factor out the greatest common factor. So if I look at my 2 terms, I have 2x to the third, and I have a minus 8x squared. In both of those terms, I have a factor of 2, and I have a factor of x squared. I don't have an x to the third in both of them. I only have an x squared at most. And then what you would do in parentheses, you would write what's left over. So if I have 2x to the third, and I take out of that 2x squared, what I'm left is a 1x. And if I take a 2 out of the 8, factoring it, remember, so factoring is when we break it down with multiplication. So 2 times what gives me 8? We want to think about it in reverse of multiplication versus addition or subtraction. So if I break 8 down into 2 times something, what would be left if I take out the 2 would be the 4. Because 2 times 4 is 8, and I would take out the 2. And if I pull out the x squared, then I have no more x's in there. So my final answer when it's factored would be 2x squared, and then in parentheses I would have x minus 4 left over. Now, if I want to go backwards to check, I would just distribute. So I would take the 2x squared times the x, and I would get 2x to the third, and then I would take 2x squared times the minus 4, and that would give me a minus 8x squared. So you can check it by multiplying it back out, and if you get the same thing, then you factored it correctly. Okay, next example, factoring out the greatest common factor, we're looking to see at most what we can pull out of each term. I have a 15 and a 20 here. If I break it down into its factors, at most there is a 5 in common. If I look at the A's, at most I have 1 A in common. And if I look at the B's, at most I have 1 B in common. And then inside the parentheses, I'm going to write what I have left over. If I write 15 as 3 times 5 and I pull out the 5, I'm left with a 3. If I have 2 A's and I pull out an A, I'm left with 1 A. If I have 1 B and I pull out a B, then I'm going to have no B's left in there. And then I have minus And then if I take a 5 out of the 2 times 2 times 5, what I'm left is the 2 times 2, which is a 4. If I have one A and I take out an A, I have no A's left. And if I have 2 B's and I pull out a B, then I have 1 B left. So this would be factored. And then I can check it by multiplying it back out. So I would take 5AB times 3A, and I would get 15A squared B. And then I would take the 5AB times the minus 4B, and I would get the negative 20AB squared. And then I look to see if it's the same thing, and so it works. Okay, in the next example, in all of my coefficients, 9, 12, and 6, they all contain a 3. 9 is 3 times 3, 12 is 4 times 3, and 6 is 3 times 2. So they all contain a 3. So I can factor out a 3 out of all of them. And then in the first term, I have 3 x's. In the second term, I have 2 x's. And in the third term, I have 1 x. So at most, they all have in common 1 x. So I can factor out 1 x. And in all terms, I have a y squared. So I can pull a y squared out of every term. And then in all terms, I have at most a z in common. So I can pull out a z. And now we got to write what's left over on the inside. So in the first term, if I pull a 3 out of the 9, I'm left with a factor of 3. If I have 3 x's and pull out 1 x, that leaves me with 2 x's left. If I have a y squared and I pull out a y squared, I have no y's left. And if I have a z and I pull out a z, then I have no z's left. Now looking at the second term, if I pull out a 3, I'm left with a 4 for the 12. If I have 2 x's and I pull out an x, I'm left with 1 x. And I pulled out all the y's in that one. And for the z's, if I have 2 z's and pull out 1 z, I'm left with 1 z on the inside. And the last term, if I pull the 3 out of the 6, I'm left with a 2. I have 1 x and I pulled out an x, so I have no x's left. I pulled out 2 y's out of the y squared, so I'm left with no y's in the third term. And then z to the third, if I pull out 1 z, that leaves me with z squared. Now we can check it. So I'm going to take 3x y squared z and multiply it by the first term. That's going to give me 9x to the third, because I have 1x and 2 x's, that gives me 3 x's. Then I have y squared z. This is going back using our exponent rules. We want to add our exponents with like bases. I have a 3 times a minus 4, that gives me minus 12. And then I have x times x, which is x squared. Then I have y squared. And then I have z times z, that gives me 2 z's, so z squared. Then I have 3 times a negative 2, that gives me a minus 6. Then I have an xy squared, and a z times a z squared gives me a z to the third. So when I check that with my original problem, that works. Okay, last example for pulling out the greatest common factor. In all of these, I don't have any numerical factor in common. I don't have A's in every single one of them. I don't have B's in every single one of them. And I don't have X's in every single one of them. So this one does not have a greatest common factor. Now that we've talked about pulling out a greatest common factor, which is the easiest method to factoring, and we have an idea of what factoring is, now we're going to get into the more specific methods that we need to use to factor when it's based by terms. So whenever you approach any kind of factoring problem, you first want to see if the terms have a greatest common factor, and pull that out first. And then whatever's left over, you want to see if you can factor it further. And you choose the method based on the number of terms you have. So now that's what we're going to get into. We're going to look at the different methods based on the number of terms. And then, of course, you always want to check your answer by multiplying back out. So when you have 4 terms, you want to do factor by grouping. And if you notice in example A here, I have 4 terms. Remember, terms are separated by pluses and minuses. And so when we use factor by grouping, we want to look at the first 2 terms and the second 2 terms separately to start off with. And so when I look at the first 2 terms, I want to look to see what the 2 terms have in common. And if you notice, there's a 3 and an x in common. And what would be left over is x plus 2. Now when you do factor by grouping, you want to make sure when you factor the second 2 terms, or the second group, that your parentheses comes out to be exactly the same. So what we need to do is figure out what to put in front of that x plus 2, so when I multiply by the x plus 2, I get a minus 4xz and a minus 8z. So what I would need to put there is a minus 4z. That way, when I multiply minus 4z times x plus 2, I get minus 4xz minus 8z. And so now we went from 4 terms, and I went down to 2 terms. Because I have, remember, terms are separated by pluses and minus. Here's a term, and then I have a minus, and I have another term. And in each of those terms, I have an x plus 2 in common. If I look at the x plus 2, they both have in common, and I pull that out, what's left is 3x minus 4z. So that's what's going to be left over in the parentheses. And now this is factored. And I know that because it's only separated by multiplication. I have one factor times another factor, and then I can check it by multiplying back out. So here I'm going to do FOIL. I take x times 3x. That's going to give me 3x squared. Then I have x times minus 4z. That's going to give me minus 4xz. Then I take 2 times 3x. That gives me a plus 6x. And then I take 2 times minus 4z, and that's going to give me a minus 8z. Now when you check that with our original, notice it's the same thing. It's a little bit out of order, but it's the same thing. Okay, let's look at example B. As usual, you always want to make sure you look to see if there's a common factor that you can pull out of all of them. And in this case, there isn't. And then you look to see how many terms there are to help you determine the method. Since there are 4 terms, we want to use factor by grouping. So I want to look at the first 2 terms and the second 2 terms separately. If I look at the first 2 terms, what they have in common is a 2 and a y squared. And what would be left over is x plus 4. Because this is factor by grouping, I want to make sure that these 2 parentheses come out exactly the same, and I've just got to figure out what goes in front of that x plus 4, so that when I apply that factor by x plus 4, I get the second group back, which is x plus 4. So in this case, this one's nice and easy. I would have to put a positive 1 in there, because if I take positive 1 times x plus 4, I'm going to get x plus 4, which is that second 2 terms. So now, if I look what they have in common, which is why we want to make sure that our parentheses come out the same, is x plus 4. Those 2 terms have x plus 4 in common, and then what would be left over would be the 2y squared plus 1. And now this is completely factored. I will leave it up to you guys to do your check. So go ahead and take a minute to pause the video and check your answer. Okay, next example, I want to check to see if they all have something in common that I can factor out. And they don't, so then I go on and look to see the number of terms that we have. Since we have 4 terms, I want to use factor by grouping. So I want to look at the first 2 terms and the second 2 terms temporarily, separately. And so in the first 2 terms, I have a 2 and a b in common. And what would be left over is a minus 5. And because this is grouping, I want to make sure that my parentheses come out the same. And I just need to figure out what goes in front so that when I multiply it by a minus 5, I get minus 5a plus 25. So I would have to put in front of that a minus 5 a minus 5. So when I take minus 5 times a, I get a minus 5a. And when I take minus 5 times minus 5, I get a plus 25. So now I have 2 terms. And in both of those terms, I have a minus 5 in common. And what would be left over is the 2b minus 5. And so now we have it factored. And I'll let you guys check your answer when you pause the video. Okay, the next method you want to use if you have 3 terms, that's called the AC method. And I call it the AC method because when we talk about quadratics later on, you take the first coefficient times the last coefficient. So that would be a times c. Okay, so in example A, you first want to look to see if there's something in common that you can pull out of all 3 terms. And there is not. So then you go on and say, well, there's 3 terms, so I use the AC method. Now the AC method is when you look at when it's in descending order, you look at the first coefficient and you look at the last coefficient when it's in descending order. I can't stress that enough, otherwise it won't work. And you take and multiply them. So the first coefficient here is 1. The last coefficient is 1, so I would take 1 times 1, so I'll label that as a times c. And then you find the factors of a times c that would add to give you a negative 2 in the middle. So the only way that you could get a product of 1 is a negative 1 times a negative 1 or a 1 times a 1. Those are the only 2 ways that you could get a positive 1 as a product. So since we want the numbers to add up to be negative 2 in the middle, I would choose this product here. So what we're going to do is we're going to rewrite a squared minus 2a plus 1 using the negative 1 and the negative 1. So I'm going to bring down the a squared, and then I'm going to rewrite the minus 2a as a minus 1a and a minus 1a and a plus 1. And I'm getting the minus 1a's because that's what adds to give me a negative 2, but multiplies to give me a positive 1. Now, the reason why we did that is because now we just made it from 3 terms to 4 terms. And since we have 4 terms, we can now use the grouping method. So the AC method is the grouping method with just 1 extra step. You take the 3 terms and you rewrite the middle term as 2 terms, so you end up with 4. So in the first 2 terms, I can factor out an a, and I'm left with a minus 1. And I want my second parentheses to be exactly the same. So I got to figure out what goes in front. So when I multiply by a minus 1, I get minus a plus 1, which is the second group of terms. Well, that number would have to be minus 1. If I take minus 1 times a minus 1, I'm going to get minus a plus 1. Well, now I have an a minus 1 in common. And what would be left over is a minus 1. So now this is factored. So the trick is, for the AC method, when you see 3 terms, we're going to rewrite it as 4 terms and then use the grouping method. And the way that we rewrite it as 4 terms is we look at the product of the first coefficient times the last coefficient, and we find a product that those 2 factors add to the middle term. And that's what we use to break down the middle term. Okay, next example, I have a squared minus 5a plus 4b squared. It's in descending order, so I want to look at the first coefficient and the last coefficient. So that would be a 1 times a 4, which would give me 4. So I want to look at all my possible factors of 4. I could have a 4 times a 1, or I could have a negative 4 times a negative 1. But I want to pick the factors that would add to give me a minus 5 in the middle. So in this case, I'm going to use minus 4 minus 1. And I'm going to rewrite that minus 5ab as a minus 4ab and a minus 1ab. So I'm going to bring down the a squared. I'm going to rewrite it as minus 4ab minus 1ab plus 4b squared. Okay, now I have 4 terms and I can use the grouping method. So I'm going to look at my 2 groups separately. In the first group, I have an a in common, and what's left over would be a minus 4b. I want to make sure that my parentheses are the same, so I've got to figure out what goes in front of the second parentheses. So when I multiply it, I get minus ab plus 4b squared, which is my second group of terms. Well, what I would have to put there would be a minus b. So now I have a minus 4b in common. And what's left over is a minus b. So that's what's going to go left over inside the parentheses. And so now it's factored. And again, you can multiply it back out to check it. The next example, look to see if they have anything in common you can pull out first. And there is none. So then we jump down and say, okay, well, I see 3 terms, so I want to use the AC method. So I'm going to look at the first coefficient and the last coefficient. That's 1 times 1, which would give me 1. And I want to find factors of 1 that would add to give me negative 2 in the middle. That would be the negative 1 and the negative 1. So I'm going to break down the minus 2y as a minus 1y and a minus 1y. And so now we have 4 terms and I can use grouping. And the first 2 terms, I have a y in common. I want to make sure my parentheses are the same. So I got to figure out what goes in front of the second parentheses. So when I multiply it by y minus 1, I get the second group of terms, which is minus y plus 1. So what would have to go in front of here is a negative 1. So now I have a y minus 1 in common. And what's left over would be y minus 1. And so now it's factored and you can check your answer. Okay, in example D, you always want to first look to see what they have in common, if anything, that you can pull out. And in this example, they do have a common factor that you can pull out. You can pull out a 2 to start off with. So you're left with a squared plus 2a minus 15. If you do have something in common that you can pull out, then you want to just make sure that you keep carrying that 2 down and make sure it's included in your final answer. So now we're going to use the AC method to break down the a squared plus 2a minus 15. So think of this example. If we look at a numerical example of this, let's say I ask you to factor 12. So you pick two numbers that multiply to give me 12. Let's say 6 times 2. But that's not completely factored because I can still break the 6 down into 3 times 2. So that's exactly what's going on here. I broke down 2a squared plus 4a minus 30 into 2 times a squared plus 2a minus 15. But that a squared plus 2a minus 15 still can be broken down again, just like the 6 over here. So I want to make sure that I keep carrying that 2 down in front while I'm breaking down that 6. So the same thing here, I want to make sure I keep breaking down or bringing down that 2 while I break down the a squared plus 2a minus 15. Okay, so I want to take the first coefficient, which is 1, times the last coefficient, which is negative 15, and that gives me a negative 15 when I multiply them. And so now I want to look at all my factors of negative 15. I could have negative 15 and positive 1, or I could have negative 1 and positive 15. I could have 3 and negative 5, or I could have negative 3 and positive 5. Those are all my possibilities. So I want to find the factors that would multiply to give me negative 15, but add to give me a positive 2. So that would be this pair right here. The negative 3 and the positive 5 would add to give me a positive 2, but multiply to give me a negative 15. So I'm going to carry down the 2, and I'm just going to break up that a squared plus 2a minus 15 into 4 terms using that negative 3 and the positive 5. So I have a squared, and then I'm going to rewrite the 2a as a minus 3a plus 5a, and then bring down the negative 15. Now I'm going to use grouping. Bring down the 2. In the first two terms, I have an a, and I would be left with a minus 3. I want to make sure that my parentheses are the same. So I got to figure out what goes in front of the second set of parentheses. So when I multiply by a minus 3, I get 5a minus 15. Well, that would have to be a positive 5. So now I have an a minus 3 in common. And what's left over would be a plus 5. And then I still have to remember to pull down that 2. So my final answer would be 2 times a minus 3 times a plus 5. So in this case, we have 3 factors, the 2, the a minus 3, and the a plus 5. Okay, example E, we have 1/9 x squared plus 2x plus 9. Now, they don't all have a specific factor in common. So then I'm going to go and say, okay, well, I have 3 terms, so I'm going to use the AC method. So I take the first coefficient times the last coefficient. So I take 1/9 times 9, and I get 1. I want to find the factors of 1 that would add to give me 2. So the only factors of 1 would be negative 1 times negative 1, or positive 1 times positive 1. And I want it to add to 2. So I'm going to use positive 1 and positive 1. So I'm going to carry down the 1/9 x squared, and then I'm going to rewrite the 2x as plus 1x, and then bring down the 9. And now I can use grouping. In the first two terms, I have an x in common. So when I factor that out, I get 1/9 x plus 1. Now I want to make sure I have the same parentheses over here. So I got to figure out what I would multiply 1/9 x plus 1 by to get the second group, which is x plus 9. Well, that would have to be 9, a positive 9. So now I have these two factors in common. So I have 1/9 x plus 1, and what would be left over is the x plus 9. That's going to go in the inside of the parentheses left over. And so now this is factored. Okay, last example for AC method. If you look, they all have a greatest common factor. They all have a 2x squared in common. So I'm going to factor out 2x squared, and I'm going to be left with x squared plus 6xy plus 9y squared. So here's my greatest common factor that I pulled out, but I still need to check to see if this, what's left over in the parentheses, can be factored. And since that's 3 terms, we're going to use the AC method to factor the x squared plus 6xy plus 9 squared. I want to look at the first coefficient times the last coefficient, so that would be 1 times 9. Right? First times the last. So that's going to give me a 9, and I want to find all the factors of 9. So I could have -1, -9, +9 and +1, and then I could have 3 and 3. I got to find which one of those pairs would add to give me 6. It would be the 3 and the 3. So I'm going to break up that 6xy with using 3 and 3 for coefficients instead, keeping in mind that I still have to carry down my coefficient here in front, my greatest common factor in front. So I'm going to rewrite 6xy as 3xy plus 3xy. Now I can use grouping. I'm going to bring down the 2x squared again. In the first two terms, I can pull out an x. That leaves me with x plus 3y. And I want to make sure that my parentheses are the same. So I want to figure out what goes in front here. So when I multiply it by x plus 3y, I get 3xy plus 9y squared. So that would have to be a positive 3y. So bringing down my 2x squared, I see that I have x plus 3y, which is the same in both of those terms. So I'm going to factor that out. And then what's left over is the x plus 3y. So that's what's going to go left over inside the parentheses. And so here is my final factored form. And then you can multiply it back out and check it. Okay, so now we're down to the methods that we use if we have 2 terms. There are 4 methods. We could have the sum of squares, we could have the difference of squares, or we could have the sum of cubes or the difference of cubes. And so let's work on the sum of squares first. The sum of squares is going to be prime unless there is a greatest common factor that you can pull out. And prime means there is no way to factor it other than that factor times 1. So if I look at x squared plus 4, what comes to mind for me to try would be to try x plus 2, x plus 2, or we could try x minus 2, x minus 2, because the x times the x would give me the x squared, and the 2 times the 2 would give me the 4. However, when we multiply that back out to check it, if I take x times x, that gives me x squared. Then if I take x times 2, that gives me 2x. And then if I take 2 times x again, that gives me 2x. And then the 2 times the 2, that gives me a 4. And so when I multiply that out, what I end up getting is x squared plus 4x plus 4, which is not equal to x squared plus 4. So this is not the correct factorization for x squared plus 4. And it's because of this 2x and this 2x. In order for that middle term to disappear with the x's, one has to be plus and one has to be minus to add to 0. And that doesn't happen with this. And the same thing goes for x minus 2 times x minus 2. I would get the same thing, only I would have minus 2x's in the middle, which would leave me with x squared minus 4x plus 4, which again does not equal x squared plus 4. So this also does not work. So what happens is, with the x squared plus 4, you want to get rid of the middle term, but that's impossible if these two signs are the same. And if I switch the signs and make it x minus 2, x plus 2 so that the middle term disappears, well, now that gives me a minus 2 times a positive 2 on the end, which would not give me a positive 4. So this also doesn't work. So for part A, this is impossible to factor over real numbers. So we would call this prime. It's not factorable. So when you have the sum of squares, you would say that that's prime, unless, of course, there is something that they both have in common that you can pull out. Now, I can tell that this is the sum of squares because x squared is x times x, and 4 is 2 times 2. They're perfect squares. I can rewrite this as x squared plus 2 squared. So if you have a polynomial with 2 terms, with the plus in the middle, and both terms are perfect squares, it's not going to be factorable over the real numbers, and you would just say that it's prime. In part B, there is, however, a greatest common factor that I can pull out first. So I can pull out a 3, and I'm left with x squared plus 9. Now this is the sum of squares. So this part here is prime, the x squared plus 9. I can't factor that anymore. There isn't a way to do it. For the same reason I just showed you in example A. I can't write that as x plus 3 times x plus 3. I can't write it as x minus 3, x minus 3. And I can't write it as x minus 3, x plus 3 with the sign switch because that would give me a minus 9 on the end. So this is as factored as you're going to get for 3x squared plus 27. Now the difference of squares is factorable. So if you have perfect squares but it's separated by a minus, that will work. I can factor that. So if you look at it in terms of the AC method, I'm just going to put in a 0x as a placeholder here. And since I just made it into 3 terms, I'm going to use the AC method. So I'm going to look at the first coefficient times the last coefficient. So that's 1 times a negative 9, which is a negative 9. And I'm looking for factors of negative 9 that will add to give me a 0x in the middle. So negative 3 and positive 3 will work. So if I rewrite 0x in the middle, 3x and a minus 3x, and then I go ahead and use grouping. So in the first 2 terms, I can pull out an x. I want to keep my parentheses the same. And I got to figure out what goes in front of the second parenthesis. So when I multiply it by x plus 3, I get a minus 3x minus 9. So that would have to be a minus 3. So what they have in common is the x plus 3. And what's left over is x minus 3. When you see the difference of squares, that means you have a subtraction sign in the middle, and you have 2 perfect squares on each end, and you can factor it using the shortcut. Ask yourself, What are the same two exact things that would multiply to give me the first term? In this case, it would be x and x, so I would put that here and here. And then what are the same exact two things that would multiply to give me 9? That would be 3 and 3. And then you just switch the sign plus and minus, so the middle term adds up to 0. And then you just left with the first term and the last term, and the middle term disappears. So now using the shortcut, this is a perfect square and this is a perfect square, and it's separated by a minus. So I'm going to use the shortcut. What two things would give me 9x squared when I multiply them that are exactly the same? Well, that would be 3x and 3x. What two things exactly the same would give me 4y squared when I multiply them? That would be 2y and 2y. And then I do plus or minus in the middle. So when I multiply this out, I get positive 2y times negative 2y to give me a minus 4y squared. I get the 3x times the 3x, which would give me the 9x squared in the front. And then the two middle terms disappear because they add to 0. Okay, in the next example, part C, it's a difference of squares with one extra step. If you notice, both terms have a 10 in common. So you always want to approach any factoring problem to look to see if they have something in common first. In this case, they do. I can pull out a 10, and I'm left with 49 minus t squared. So now I'm going to continue factoring using my shortcut with the difference of squares. I need to ask myself what two things exactly the same would multiply to give me 49? Like 7 and 7. What two things exactly the same would multiply to give me t squared? That's t and t. And then I would do plus or minus in the middle. So this would be my complete factored form for 490 minus 10 t squared. Okay, last example for difference of squares. I have x to the fourth minus 16. This is definitely perfect squares, and I have a minus in the middle, so I can use my shortcut. What two things would multiply to give me x to the fourth that are exactly the same? X squared and x squared. What two things are exactly the same that would multiply to give me 16? 4 and 4. So then I separate it with a plus or minus. However, this one's a little tricky because we're not completely done. If you notice, we broke this down into x squared plus 4 and x squared minus 4. This is the sum of squares, which we know is prime. We can't factor that anymore. But this one here is the difference of squares. We can actually factor this one more time. It's the same example that I gave you previously. If I take 12 and I break it down into 6 times 2, I can still break that 6 down into 3 times 2. And I bring down that other 2. So the 12 was not completely factored when I left it as 6 times 2. I still have to break it down again if I can. And that x squared minus 4 can be broken down again. The x squared plus 4 cannot, so I leave it as x squared plus 4. And the x squared minus 4, since that's the difference of squares, I can use my shortcut again. Two things to multiply to give me x squared that are exactly the same are x and x. And then two things exactly the same to multiply to give me 4 would be 2 and 2. And then I put in a plus or minus. Now we are completely factored over the reals. Okay, the last topic for if we have two terms and we're trying to factor is the sum and difference of cubes. And when we factor the sum and difference of cubes, we're going to use a factoring formula to make things a little bit easier. And the formulas are in this box here. And you don't have to worry about memorizing those. If you use them on a test, I'll make sure you have them available to you. Remember, a perfect square is if you can write it as something squared. For example, 16 can be written as 4 squared. So 16 is a perfect square. Well, the same idea goes for cubes. For example, 8 is a perfect cube because I can write it as 2 cubed. So anything that can be written with the base raised to the third power is a perfect cube. So in this case, in example A, we have the sum of cubes. I can write x to the third as x to the power of 3. I can write 8 as 2 to the third. So I have the sum of cubes. So since I have the sum of cubes, I want to look at this formula here, a cubed plus b cubed. So I want to look at my x as my a and my 2 as my b in my formula. My a will be x and my b will be 2. So in my formula, I'm just going to replace all my a's with x's and all my b's with 2's. So I would have x cubed plus 2 cubed is equal to, and then if you look, I have a plus b. Because a is x and b is 2, I would have x plus 2. And then I would have a squared. Since a is x, that would be x squared. Then I would subtract a times b. A times b would be 2 times x. And then b squared would be 2 squared, which would be 4. So this is equal to x to the third plus 8 using our formulas. The hardest part with these is just identifying what your a and b is. Then once you do that, you just plug it into your formula and you're done. So looking at example B, in here I can factor out a 10. You always still want to make sure you look to see if there's a greatest common factor you can pull out first. And in example B there is. So I can pull out a 10 and I'm left with x to the third minus 125. Now I can factor this as the difference of cubes. X cubed is the same thing like this. X to the power of 3. So a is x in this case. And 125 can be written as 5 to the third. So b is going to be 5. So looking at my formula, and because this is the difference of cubes, I'm going to use the first formula in the box, a to the third minus b to the third. I'm going to use the factor a minus b first. Since in this case, a is x, I have x, minus b, in this case, b is 5, so I have minus 5. And then I have a squared, which is x squared, plus ab. Since a is x and b is 5 in this case, I would have 5x. And then b squared, which would be 5 squared, which is 25. So this would be completely factored for 10x to the third minus 1,250. Okay, last example for sum and difference of cubes. I can write a to the third like this, and I can write 8 over 27 as 2/3 to the third, because 2 to the third is 8 and 3 to the third is 27. So I can identify little a as big A in my formula, and 2/3 is b. So in my difference of cubes formula, I'm going to do a minus b. So this is going to be little a minus 2/3. And then I'm going to have a squared plus a times b. A times b would be 2/3 a. And then plus b squared, since b is 2/3, 2/3 squared would be 4/9. And so this would be my final answer for factored form of a to the third minus 8 over 27.